let's draw something to understand exactly what is happening. But before, we're going to look at that. So here we're using the last pointer, the P pointer, and then we're trying to change the value to 12. So let's see what will display. Instead of 10, the value will be 12. So gcc main.c, then output file name. Great. Then let's execute the file. So here, instead of 10, we see that it displays 12. So we use the last pointer to dereference as many times as needed to be able to access this address. Now, let's draw something. I think this will give us a very good understanding of what is going on. Oh, sorry. OneNote. This is the editor we're going to use. Great. So the layout of the memory looks something like that. We have values. I'm going to draw this. This represents a value. And then the other represents the value, the address of the value. So I'm going to move it here. This one, the last one. Change the size and the color. Copy it. And we add other squares to represent the addresses. Great. So each of these represent a memory location. So I'm going to enclose these with something like that, or it's not important for now. So when you declare a variables like the variable a, we have variable a, make the text a little bigger, okay? So we have the variable a, then we have the pointer to the variable a. Great. Then we have another pointer that points to the variable p. Then we have another pointer that points to the variable pp, and another variable that contains the address of ppp. Okay. So we're going to stop here for pp. So now the value 10 is stored in here. Let's say the addresses are something like 1, 2, 3, 5, 1, 2, 3, something like that. 1, 2, 3, 5, 1, 2, 3, 6, 1, 2, 3, 7, and 1, 2, 3, 6, 9. So we have memory locations. In each of these memory locations, we have values on the green columns. So the P variables, its value is 1, 2, 3, the address of A. And the PP variables, since it is a pointer to a pointer that points to an integer value, its value will be 1, 2, 3, 5, the same as here, the same as the address of the P variables. Then the other PP variables, its value will be the address of a variables that is a pointer that points to another pointer, which points to a variables, um, an integer variable. So its value will be 1, 2, 3, 6. And the other pointer is a variables that contain a value, but its value is 1, 2, 3, 7. I'm going to draw a bit here. So this is a variables. This is our variables. The A variable is contained the value 10. Then the P variables is a pointer to an address. So its value is the address of A. Then the value of the PP variables, its address, its value will be that. And what else? We continue like that. This pointer, its value is the address of the pointer PP, and that's it. So what happens when you try to do dereferencing, when you are using dereferencing, you're telling the compiler, let's start from here. You add a first start. You say, okay, like in this code here, we add 1, 2, 3, 4, 5. So we did 5 dereferencing. So the first one will be to jump from here to here. So the next dereferencing will be, we go up like that till we get to the value. So at each dereferencing, we have access to the value. So when we dereference from this, the 1, 2, 3, 7, the compiler will be looking for its value. And when we do another dereferencing, the compiler will look for the memory location 1, 2, 3, 6, then we'll get the value. And you do another dereferencing, it will go up and it will look for the memory location 1, 2, 3, 5, then which is here. Then we have the value. You do another dereferencing, it will look for the address 1, 2, 3. So here we have the address of the memory location 1, 2, 3. Then we have the value. So at each time you apply the dereferencing operator, the compiler look for, or the system look for, the memory locations that is represented by the value. Great. So I think that this is it for pointers to pointers. It is no magic. It is a funny way of, it's like, it's a bit funny how it works. But that's it. Now let's go back to our matrix. When you declare, you can declare something like that, and the matrix great. So the matrix can be an array of pointers. So we can say something like that. An array of 5 pointers. So this is an array of 5 pointers that point to, that for now, they're not pointing to anything. But what will happen here, let's go back to our drawing. I'm going to delete all this and the values also. So when you declare an array of 5 pointers, you will have 5 variables or 5 memory location reserved for your array, but the values they can contain are addresses. So this array can contain addresses to other variables. So here we can declare something like 5 variables: variable A, B, C, D, E, F. So we have 5 variables. Then we're going to initiate the value of A to 10. B will be equal to 11. C is equal to 12. D will be equal to 30. And E will be equal to 40. Then now we're going to set the addresses or the pointers that are in our matrix array. So what will happen, we'll have for the first elements or for the first pointers in the array, we're going to set its value to the address of A. Then for the second, we're going to set its value to the address of B. Then the third, we're going to set its value to the address of C, and so on. So we can have an array of pointers. We can have an array of pointers. We can have an array of pointers that point to other pointers that point to another pointer. Now let's try to display this matrix. It will be something like, I'm going to declare another variables. I'm going to call it I. Okay. So for I is equal to 0, I lesser than 5, I plus plus. We're printing the content of the matrix. So we have matrix A, the index I. Then we're going to use the dereferencing operator to access the value, because at each element or each element of this matrix array is a pointer. We may need to change the name of these variables because I think matrix might get us a bit confused. So we're going to say array of pointers. I'm going to change the name. Great. So for each pointer, we assigned an address in the array. Then after that, we are displaying the values stored in the addresses to which the elements of these arrays are pointing to. So let's run the GCC command and execute this code. GCC main.c, the output file name, Great. Then and here, with no surprise, we see that it displays 10, 11, 12, 13, 40, the same values as for A, B, C, D, and E. So pointers, they are not magic. They are just variables that takes their value from a specific set or domain. So when you declare something like int matrix, then you type in something like 3. So here, for the first square bracket, you are declaring a pointers that point to 3 variables. So you're declaring an array of 3 integer. But when you add another square bracket, you're now declaring an array that point to 3. For example, here 5, that is pointing to, you're declaring an array of 3 pointers that point to an integer value. And when you add another square bracket, so you can go as deep as you want. I don't know what is or are the limitation for the C programming language, but this syntax is correct. You might even go more deeper if you know what you're doing. Maybe the task requirements or the project requirements may add something like that. We don't know. So you're here, we're declaring this is a, for the first level, we're having 3 pointers of pointers or pointer that point to an integer. And these also, we're having 3 other pointers. So visually, it is not very easy to kind of draw this kind of representation, but we can easily draw things for um, 3-dimensional arrays or 2-dimensional arrays. But above that, it gets a bit complicated to draw something that makes sense. But either way, this is how it works. You can declare pointers to pointer to pointers to pointers to pointers as long as many as you want. So this is for these things about pointers. For the recap, a pointers is just a value, is just a variables, and that variables can contain values. But depending on the types of value, we might say a pointers or a pointer that point to another pointers, or a pointer that point to another pointers that point to an integer value. So um, the deeper you go, the more dereferencing operation you might need to get access to the specified value.